Hello, in this lecture we will find the radius of the circle. In the drawing we have a circle, and inside the circle we have quadrilateral ABCD. Actually, quadrilateral ABCD is inscribed by this blue circle, and we know that side AB of quadrilateral ABCD equals to 3 units, so we will define side AB as B, therefore B will be equal to 3 units, and we also know that side BC of quadrilateral ABCD equals to 3 units in its size, so we will define side BC as B, that is to say BC equals to B, therefore B will be equal to 4 units. And we also know that side CD of quadrilateral ABCD equals to 5 units in its size, so we will define side CD as C, therefore C will be equal to 5 units. And we also know that side AD of quadrilateral ABCD equals to 6 units, so we will define side AD as D, therefore D will be equal to 6 units. And we actually want to find out the radius of this circle that blocks quadrilateral ABCD. So first of all, I will present to you 3 new rules, and we will implement those new rules in our drawing. The first rule is rule number 1. According to rule number 1, the area of quadrilateral ABCD inscribed by a circle equals to actually this is the sign of area, and this is the area of triangle ABC. It equals to, according to rule number 1, to the root of S minus A times S minus B times S minus C times S minus D, when A, B, C, and D are the lengths of quadrilateral ABC sides. In this case, A equals to, this is actually A equals to 3 units, B equals to 4 units, C equals to 5 units, and D equals to 6 units, and S equals to A plus B plus C plus D over 2. So actually, if we have this circle and we have actually this circle blocks quadrilateral ABCD, following quadrilateral ABCD in the red color is inscribed by this circle, and we also know that side AB equals to A units in its size, side BC equals to B units in its size, side CD equals to C units in its size, and side AD of quadrilateral ABCD equals to D units in its size. So according to rule number 1, if we have a quadrilateral that is inscribed by a circle like in this drawing, then the area of this quadrilateral ABCD will be equal to the root of S minus A times S minus B times S minus C times S minus D. Again, A, B, C, and D are the lengths of this quadrilateral ABCD sides, and S equals to A plus B plus C plus D over 2. Okay, this is actually rule number 1. And we also have rule number 2. Rule number 2 states that if quadrilateral ABCD is inscribed by a circle, then so it is true only rule number 2, and also rule number 1. Both those two rules are true only if the quadrilateral is inscribed by a circle, otherwise it is not true. So if we have quadrilateral ABC that is inscribed by a circle, or the circle blocks the quadrilateral, then the product of its diagonals equals to the sum of products of its opposite sides. I will read rule number 2 again. Rule number 2 states that if quadrilateral ABCD is inscribed by a circle, then the product of its diagonals equals to the sum of the products of its opposite sides. So, what is the meaning of rule number 2? The meaning of rule number 2 is actually, if we have this circle and inside this circle we have quadrilateral ABCD, or in other words quadrilateral ABCD is inscribed by this blue circle. So this is quadrilateral ABCD, and this quadrilateral is described by this blue circle, and we also know that side AB equals to A units in its size, side BC of quadrilateral ABCD equals to B units in its size, side CD of quadrilateral ABCD equals to C units in its size, and side AD equals to D units in its size. Then I repeat again that rule number 2 is true only if we are talking about quadrilateral that is inscribed by a circle like in this drawing, and the quadrilateral ABCD has two diagonals, diagonal AC and the size of diagonal AC will be defined as X units, and the second diagonal BD will be defined by Y, that is to say it equals to Y units in its size. So according to rule number 2, the product of its diagonals, the product of quadrilateral ABCD diagonals is X times Y, and X times Y equals to, according to rule number 2, equals to the sum of products of its opposite sides. It's equals to the sum of products of its opposite sides. So actually quadrilateral ABCD has two pairs of opposite sides. The first pair of opposite sides is side AD is opposite to side BC, and side AD equals to D units in its size, and side BD equals to side BC equals to B units in its size, and the product of those opposite sides is B times D. And actually quadrilateral ABCD has second pair of opposite sides. Side AB is opposite to side DC, and the product of those two opposite sides, it is actually A times C. And according to rule number 2, the product of its diagonals, that is to say X times Y, equals to the sum of the products of its opposite sides. And the sum of the product of its opposite sides, it is actually BD plus AC. So the sum of the product of its opposite sides, that is BD plus AC, equals to the product of its diagonals, that is actually X times Y. Okay? So actually this is rule number 2. If you have a quadrilateral that is inscribed by a circle, then the product of its diagonals, that is to say X times Y, will be equal to the sum of the products of its opposite sides. Will be equal to BD plus AC. Okay? Because actually quadrilateral ABCD has two pairs of opposite sides. AD is opposite to BC, and the product of those two opposite sides is BD, and the second pair of opposite sides is AB is opposite to DC, and the product of those two opposite sides is AC. So we have two products for the two pairs of the opposite sides, and the sum of the products of the opposite sides, it is actually BD plus AC. And that sum of the products of the opposite sides, it is equals to the products of its diagonals, that is to say it equals to x times y. So that is rule number 2. And here also have rule number 3. Rule number 3 states that if we have, according to rule number 3, if a triangle is described by a circle, if triangle ABC is inscribed by a circle, then the radius of that circle equals to the product of triangle ABC sides over 4 times the area of triangle ABC. So I will read rule number 3 again. Rule number 3 states that if triangle ABC is inscribed by a circle, then the radius of that circle equals to the product of triangle ABC sides over 4 times the area of triangle ABC. So what is the meaning of rule number 3? The meaning of rule number 3 is that if we have this circle and this circle blocks triangle ABC, that is to say triangle ABC is inscribed by this circle I will repeat again that it is true, this rule number 3 is true only if you are talking on triangle that it is inscribed by a circle. If the triangle is not inscribed by a circle, the rule is not true. So we have this triangle ABC that is inscribed by this blue circle, and we know that side AB of triangle ABC equals to A units in its size, side BC of triangle ABC equals to B units in its size, and side AC of triangle ABC equals to C units in its size. So according to rule number 3, if we have triangle that is inscribed by a circle like in this drawing, then the radius of the circle that blocks the triangle, that is to say capital R, will be equal to the product of triangle ABC sides and the product of triangle ABC sides, it is actually A times B times C over 4 times the area of triangle ABC, over 4 times the area of triangle ABC. So according to rule number 3, whenever you have a triangle that is inscribed by a circle, then you can find out the radius of that circle that blocks the triangle. According to this formula, the radius will be equal to the product of the triangle's sides. In this case, it is actually A times B times C over 4 times the area of the triangle, over 4 times the area of triangle ABC in this case. Okay, so that is rule number 3. So we'll actually implement those 3 rules in our drawing. So here, according to rule number 1, the area of this quadrilateral ABC will be equal to the root of S minus A times S minus B times S minus C times S minus T, when A, B, C, and D are the lengths of the quadrilateral sides. In this case, A is 3, B equals to 4, C equals to 5, and D equals to 6. And S equals to A plus B plus C plus D over 2. This is according to rule number 1. And we will also implement rule number 2 in our drawing. Actually, quadrilateral ABCD is 2 diagonals. The first diagonal is diagonal AC, and we will define diagonal AC as x, that is to say the size of diagonal AC is x units, and quadrilateral ABCD is also the second diagonal, diagonal BD, and we will define diagonal BD as y, that is to say the size of diagonal BD is y units. So according to rule number 2, when you have quadrilateral that is inscribed by a circle, like in this drawing, the product, when we have quadrilateral ABCD that is inscribed by a circle like in this drawing, then the product of its diagonals, that is to say x times y, will be equal to the sum of the products of its opposite sides, and the sum of the products of its opposite sides is actually BD plus AC. And repeat again, according to rule number 2, when we have quadrilateral that is inscribed by a circle, then the product of its diagonals, that is x times y, will be equal to the sum of the products of its opposite sides, that is actually BD plus AC. And we will also implement rule number 3 in our drawing. According to rule number 3, if we have, for example, this triangle ABC is inscribed by this blue circle. Therefore, the radius of this blue circle will be equal to the product of triangle ABC sides, that is to say it will be equal to A times B times X over 4 times the area of triangle ABC. Okay, so I will repeat again. According to rule number 3, if we relate to triangle ABC is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this blue circle that blocks triangle ABC will be equal to the product of triangle ABC sides, that is to say it will be equal to A times B times X over 4 times the area of triangle ABC. So here we will multiply equation number 3 by the area of triangle ABC, and we will get that r times of the area of triangle ABC equals to ABX over 4. Here we will divide equation number 4 by r, and we will get that the area of triangle ABC according to equation number 4 will be equal to ABX over 4r. So we divided equation number 4 by r, and we got that the area of triangle ABC equals to ABX over 4r. So in the next step we will focus on triangle ADC. So actually this triangle ADC is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this blue circle that blocks triangle ADC, that is to say capital R, will be equal to the product of triangle ADC sides, that is to say it will be equal to C times D times X over 4 times the area of triangle ADC. So I'll repeat again. If you focus on triangle ADC, as you can see from the drawing, this triangle ADC is inscribed by this blue circle. Therefore, according to rule number 3, the radius of the blue circle that blocks triangle ADC will be equal to the product of triangle ADC sides, that is to say to C plus D, that is to say it will be equal to C times D times X, C times D times X over 4 times the area of triangle ADC. Here we multiply the area of triangle ADC, we multiply equation number 5 by the area of triangle ADC, and we will get that r times the area of triangle ADC equals to CDX over 4. So here we will divide the equation number 5 by r, and we will get that the area of triangle ADC equals to CDX over 4r. So we found out the area of triangle ADC. So in the next step, we will focus on triangle So actually found out the area of triangle ADC we actually will focus on triangle BDC. We'll focus on triangle BDC. Actually, this triangle BDC, is inscribed by the blue circle. Therefore, according to rule number 3, the radius of this blue circle equals to the product of triangle BDC sides. That is to say, it will be equal to B times C times Y. B times C times Y over 4 times the area of triangle BDC. So I will repeat again. If we focus on triangle BDC is inscribed by the blue circle. Therefore, according to rule number 3, the radius of the blue circle will be equal to the product of triangle BDC sides. That is to say, it will be equal to B times C times Y over 4 times the area of triangle BDC. Here we will multiply equation number 5 by the area of triangle BDC, and we will get that R times the area of triangle BDC equals to BCX over 4. Here we will divide equation number 5 by R, and we will get that the area of triangle BDC equals to BCX over 4R. So we found out that the area of triangle BDC equals to BCX over 4R. Okay, so in the next step we will focus on triangle ABD. We will focus on this triangle ABD. This triangle ABD is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this blue circle that blocks triangle ABD will be equal to ADY over 4 times the area of triangle ABD. So I'll repeat again. We focus on triangle ABD. Triangle ABD is inscribed by this blue circle. Therefore, according to rule number 3, the radius of the blue circle will be equal to the product of triangle ABD sides. That is to say, it will be equal to A times D times Y over 4 times the area of triangle ABD. We will multiply equation number 6 by the area of triangle ABD, and we will get that R times the area of triangle ABD equals to a dy over 4. Here we divide the equation number 6 by r, and we will get that the area of triangle ABD, according to equation number 6, equals to a dy over 4r. Okay? So a dy over 4r is the area of triangle ABD, but we have already found out that the area of triangle BDC equals to so we found out the area of triangle ABD. And we have already found out, according to equation number 5, that the area of triangle BDC equals to BCY over 4r. Okay. So actually, if we combine together the area of triangle BDC, if we combine together triangle ABD with triangle BDC, we will get quadrilateral ABCD. Therefore, the area of quadrilateral ABCD will be equal to the area of triangle ABD plus the area of triangle BDC. Okay, so write it down. The area of triangle, the area of quadrilateral ABCD, according to the second equation, the area of quadrilateral ABCD equals to the area of triangle ABD, this triangle, plus the area of triangle BDC, this triangle. So I will repeat again. The area of quadrilateral ABCD, according to equation number 2, equals to the area of triangle ABD plus the area of triangle BDC. So the area of quadrilateral ABCD equals to the area of triangle ABD. We have already found out that the area of triangle ABD equals to ADY over 4R plus the area of triangle BDC, and we have already found out that the area of triangle BDC equals to BCY over 4R. So here we will take a common factor out of these two expressions, a common factor y over 4r, and we will get that according to equation number 2, the area of quadrilateral ABCD so here we will take y over 4r as a common factor. So what is left after we took out y over 4r as a common factor? Here what is left in this expression is AD, and what is left in this expression is BC. So we actually found out that according to equation number 2, that the area of quadrilateral ABCD equals to y over 4r times AD plus BC. But we've already found out that according to equation number 1, the area of quadrilateral ABCD equals to the area of quadrilateral ABCD according to equation number 1 equals to we will focus on triangle ABC. Actually, triangle ABC is inscribed by this blue circle, and therefore the radius of this blue circle that blocks triangle ABC will be equal to the product of triangle ABC sides, that is to say to ABX, A times B times X, over 4 times the area of triangle ABC. So the radius of the circle that blocks triangle ABC according to rule number 3 equals to ABX over 4 times the area of triangle ABC. Here we will multiply equation number 3 by the area of triangle ABC, and we will get that R times the area of triangle ABC equals to ABX over 4. Here we divide equation number 3 by R, and we will get that the area of triangle ABC equals to ABX over 4R. So we found out the area of triangle ABC equals to ABX over 4R. In the next step we will focus on triangle ADC. So actually triangle ADC is described by this blue circle. Therefore, according to rule number 3, the radius of this blue circle will be equal to the product of triangle ADC sides, that is to say it will be equal to C times D times X over 4 times the area of triangle ADC. So, and repeat again, triangle ADC is blocked by the blue circle, therefore the radius of the circle that blocks triangle ADC will be equal to the product of triangle ADC sides, that is to say it will be equal to CDX over 4 times the area of triangle ADC. Here we will multiply the equation number 4 by the area of triangle ADC, and we will get that R times the area of triangle ADC equals to CDX over 4. Here we will divide the equation number 4 by R, and we will get that the area of triangle ADC equals to CDX over 4R. And we also know that the area of triangle ABC equals to ABX over 4R. As you can see from the drawing, if we combine triangle ABC with triangle ADC, if we combine those two triangles together, we will get the quadrilateral ABCD. Therefore, the area of quadrilateral ABCD will be equal to the area of triangle ABC plus the area of triangle ADC. So we write it down. The area of quadrilateral ABCD will be equal to the area of triangle ABC plus the area of triangle ADC. I repeat again, the area of quadrilateral ABCD will be equal to the area of triangle ABC plus the area of triangle ADC. Why? Because quadrilateral ABCD consists of those two triangles, triangle ABC and triangle ADC. Okay? So the area of quadrilateral ABCD, according to equation number 1, equals to the area of triangle ABC, that is actually ABX over 4R, plus the area of triangle ADC, that is CDX over 4R. So here we take x over 4R as a common factor of those two expressions, and we will get that the area of quadrilateral ABCD, according to equation number 1, equals to x over 4R. It is a common factor. Inside the bracket we will have here AB plus CD. So we actually found out, according to equation number 1, that the area of quadrilateral ABCD equals to x over 4R times AB plus CD. But we have already found out that the area of quadrilateral ABCD, according to equation number 2, equals to the area of quadrilateral ABCD, according to equation number 2, equals to y over 4R times AD plus BC. So we have here two different expressions for the area of quadrilateral ABCD. So we will multiply equation number 1 by equation number 2, and we will get that the area of quadrilateral ABCD squared, equation number 3, the area of quadrilateral ABCD squared equals to x times y, AB plus CD times AD plus BC over 4r squared. Here we will take a root out equation number 3, and we will get that the area of quadrilateral ABCD equals to the root of the numerator, xy times AB plus CD times AD plus BC the root of 4r squared is 4r, because the root cancels the square, and what is left is 4r. So here we will multiply equation number 3 by r, and then we will divide it by the area of quadrilateral ABCD. R times the area of quadrilateral ABCD equals to the root of x times y times AB plus CD times AD plus BC over 4. Here we will divide equation number 3 by the area of quadrilateral ABCD, and we will get the radius r that we are looking for. Okay? We will get that the radius r that we are looking for equals to the root of x times y times AB plus CD times AD plus BC over 4 times the area of quadrilateral ABCD. This is equation number 3. We have x times y in the root of equation number 3, but we know that x times y according to rule number 2 equals to AC plus BD, according to rule number 2. So we will substitute xy by AC plus BD in equation number 3, and we will get that r equals to the root of, we'll substitute xy by AC plus BD times AB plus CD times AD plus BC over 4 times the area of quadrilateral ABCD. So the only thing that is left to find is to find out the area of quadrilateral ABCD, because the other variables are known. It is given us the questions, the values of A, B, C, and D. So we've already found out the area of quadrilateral ABCD, so I will repeat on the same process again, and we will find out that the area of quadrilateral ABCD equals to the root of S minus A times S minus B times S minus C times S minus D, when A, B, C, and D are the lengths of quadrilateral ABCD. A equals to 3, B equals to 4, C equals to 5, and D equals to 6. And S equals to A plus B plus C plus D over 2. So S will be equals to A is 3, B is 4, C is 5, and D is 6 over 2. So 3 plus 4 is 7, 7 plus 5 is 12, and 12 plus 6 is 18, and 18 over 2 is 9. So we actually found out that S equals to 9. S equals to 9. So we can substitute S in this equality by 9, and we will get that the area of quadrilateral ABCD equals to the root of S is 9, S minus A, S is 9, A is 3, so it is S minus A is 9 minus 3. S minus B, S is 9, B is 4, so it is 9 minus 4. S minus C, S is 9, C is 5, so S minus C is 9 minus 5. And S minus D is, S is 9, D is 6, so it is 9, S minus D is S minus 6. So we actually found out that the area of quadrilateral ABCD equals to this expression. So the area of quadrilateral ABCD equals to the root of 9 minus 3 is 6, 9 minus 4 is 5, 9 minus 5 is 4, and 9 minus 6 is 3. So the area of quadrilateral ABCD equals to the root of 6 times 5 is 30, 30 times 4 is 120, and 120 times 3 is 360. So we found out that the area of quadrilateral ABCD equals to the root of 360 square units. Okay, so now we will substitute here the area of quadrilateral ABC in equation number 3 by the root of 360. So we'll do it now, and we will find out that the radius of the circle that we are looking for equals to the root of AC plus BD times AB plus CD times AD plus BC over the area of quadrilateral ABCD that we found out that it equals to the root of 360 all divided by 4. Okay. So the only thing that is left here in order to find out the radius of the circle that we are looking for is to substitute the values of, substitute the ABC and D by the values of 3, 4, 5, and 6 that we have, that is given us in the question. So we will get that the radius of the circle that we are looking for, according to equation number 3, will be equal to here we have so I write down that A equals to 3 units, B equals to 4 units, C equals to 5 units, and D equals to 6 units. And we'll calculate the values of these expressions. Very simple. AC, A equals to 3, C equals to 5. So 3 times 5 is 15. Plus BD. B equals to 4, D equals to 6, so 4 times 6 is 24. Plus AB. A equals to 3, B equals to 4, so 3 times 4 is 12. Plus CD. C equals to 5, B equals to 6, so 5 times 6 is 30. And we have AD. A equals to 3, D equals to 6, so 3 times 6 is 18. Plus BC. B equals to 4, C equals to 5, so 5 times 4 is 20. All divided by 360. So after I got all divided by 4, so actually got this expression for the radius of the circle that we are looking for. So here 15 plus 24 is 39. 12 plus 30 is 42. And 18 plus 20 is 38. All divided by 360 over 4. So I found out that the radius of the circle equals to this expression. Actually, the root of 39 times 42 times 38 over 360 is actually 172.9. So the radius of the circle that we are looking for equals to, according to equation number 3, it equals to the root of 172.9 over 4 units. Or in terms of numbers, the radius of the circle that we are looking for equals to 3.287 units. I'll repeat again. The radius of this circle equals to either to the root of 172.9 over 4 units, or in terms of numbers, the radius of this circle equals to 3.287 units. Okay? So that is the answer to the question. Now I will summarize the lecture. Actually, we wanted to find out the radius of this circle, and inside this blue circle blocks quadrilateral ABCD, or quadrilateral ABCD is described by this circle, and We know that AB equals to 3 units, therefore we defined AB as A, therefore AB will be equal to 3. We also know that side BC of quadrilateral ABCD equals to 4 units, so we defined BC as B, and therefore B will be equal to 4 units. We defined side CD equals to 5 units according to what is given us in the question, so we define side CD as C, therefore C will be equal to 5 units, and we also know that AD equals to 6 units, so we defined AD as D, therefore D will be equal to 6 units, and I presented to you 3 new rules. We have rule number 1 that states that the area of quadrilateral ABCD inscribed by a circle equals to, this is the sign of the area equals to root of S minus A times S minus B times S minus C times S minus D, when A, B, C, and D are the lengths of quadrilateral ABC sides, and S equals to A plus B plus C plus D over 2. So if you have quadrilateral ABCD with side AB that equals to A units, side BC equals to B units, side CD equals to C units, and side AD equals to D units, then the area of this quadrilateral that is inscribed by a circle will be equal to the root of S minus A times S minus B times S minus C times S minus D. Again, A, B, C, and D are the lengths of this quadrilateral sides, and S equals to A plus B plus C plus D over 2. And again, I will emphasize that rule number 1 is true only when you are talking about quadrilaterals that are inscribed by a circle, like in this drawing. Okay, that is rule number 1, and we also have rule number 2. According to rule number 2, if quadrilateral ABCD is inscribed by a circle, then the product of its diagonals equals to the sum of the products of its opposite sides. So what is the meaning of rule number 2? The meaning of rule number 2 is that if you have this quadrilateral ABCD that is inscribed by the blue circle, the product of quadrilateral ABC diagonals, that is to say x times y, will be equal to the sum of the products of its opposite sides, and the sum of the products of its opposite sides, it is actually BD plus AC. So x times y, the products of its diagonals, will be equal to the sum of the products of its opposite sides, that is actually BD plus AC. Okay? And again, rule number 2 is true only when we are talking about quadrilaterals that are inscribed by a circle, otherwise it is not true. Okay, this is rule number 2, and we also have rule number 3. According to rule number 3, if triangle ABC is inscribed by a circle, then the radius of that circle equals to the product of triangle ABC sides over 4 times the area of triangle ABC. So if we have triangle ABC that is inscribed by a circle, I repeat again that this rule number 3 is true only for triangles that are inscribed by a circle, like in this drawing. Otherwise, it is not true. So if we have a triangle that is inscribed by a circle, like this triangle ABC that is inscribed by this blue circle, then the radius of this circle that blocks triangle ABC will be equal to triangle ABC to the product of triangle ABC sides, that is to say, will be equal to A times B times C over 4 times the area of triangle ABC. Okay? So whenever you have a triangle that is inscribed by a circle, then the radius of the circle that blocks the triangle will be equal to the product of the triangle sides. In this case, it is A times B times C over 4 times the area of that triangle. In this case, is over 4 times the area of triangle ABC. This is all number 3. We actually implemented those 3 rules in our drawing. So rule number 1 states that the area of this quadrilateral ABCD that is inscribed by this blue circle equals to the root of s minus a times s minus b times s minus c times s minus d, when a, b, c, and d are the lengths of this quadrilateral sides. A equals to 3, b equals to 4, c equals to 5, and d equals to 6, and s equals to a plus b plus c plus d over 2. Okay, and we have also rule number 2, that if we have quadrilateral that is described by a circle like in this drawing, the product of its diagonals, that is to say x times y, equals to the sum of the products of its opposite sides, equals to BD plus AC. So x times y equals to BD plus AC. And we also have rule number 3. Rule number 3 relates to a triangle that is blocked, that is described by a circle. In this case, we have triangle ABC that is described by this blue circle. Then the radius of this circle that blocks triangle ABC will be equal to the product of triangle ABC sides, that is actually a times b times x over 4 times the area of triangle ABC. Here we multiplied the area of equation number 3 by the area of triangle ABC. We got that r times the area of triangle ABC equals to abx over 4. And then we divided equation number 4 by r, and we got that the area of triangle ABC equals to abx over 4r. Okay. Then we focused on triangle BDC. Triangle BDC is inscribed by this blue circle. So according to rule number 3, the radius of this blue circle that blocks triangle BDC will be equal to the product of triangle BDC sides, that is to say it will be equal to b times c times y over 4 times the area of triangle BDC. Then we multiplied the equation number 5 by the area of triangle BDC, and we got that r times the area of triangle BDC equals to bcy over 4. Then we divided the equation number 5 by r, and we got that the area of triangle BDC equals to bcy over 4r. Okay, then we focused on triangle ABD. This triangle ABD is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this circle that blocks triangle ABD will be equal to triangle ABD, the product of triangle ABD sides, that is to say it will be equal to a times d times y, a times d times y over 4 times the area of triangle ABD. Here we multiplied the equation number 6 by the area of triangle ABD, and we got that r times the area of triangle ABD equals to ADY over 4. Here we divided the equation number 6 by r, and we got that the area of triangle ABD equals to ADY over 4r. Okay, but we have equation number 5 that states that the area of triangle so according to equation number 6, the area of triangle ABD equals to a dy over 4r. Then we focused on triangle BDC. Triangle BDC is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this circle that blocks triangle BDC will be equal to the product of triangle BDC sides, that is to say it will be equal to B times C times Y over 4 times the area of triangle BDC. Okay? So we found out that the area of triangle BDC equals to BCY over 4R. Okay? So if we combine the area of triangle ABD with the area of triangle BDC, we will receive the area of quadrilateral ABCD. So according to equation number 2, the area of quadrilateral ABCD will be equal to the area of triangle ABD plus the area of triangle BDC, because of the fact that quadrilateral ABCD consists of those two triangles, triangle ABD and triangle BDC. Okay? But we already found out that the area of triangle ABD equals to ADY over 4R and the area of triangle BDC equals to VCY over 4R. So we took a common factor of y over 4R out of these two expressions, and we got that the area of quadrilateral ABCD equals to y over 4R times AB plus times AD plus BC. Then we focused on triangle ABC. Triangle ABC is blocked by this blue circle, then therefore according to rule number 3, the radius of this blue circle that blocks triangle ABC will be equal to the product of triangle ABC sides, that is to say it will be equal to A times B times X over 4 times the area of triangle ABC. So we multiplied equation number 3 by the area of triangle ABC, and we got that R times the area of triangle ABC equals to ABX over 4. Here we divided equation number 3 by R, and we got that the area of triangle ABC equals to ABX over 4R. Then we focused on triangle ADC. Actually, triangle ADC is inscribed by this blue circle, therefore according to rule number 3, the radius of this blue circle that blocks triangle ADC will be equal to the product of triangle ADC sides, that is to say it will be equal to C times D times X, C times D times X over 4 times the area of triangle ADC. We multiplied equation number 4 by the area of triangle ADC, and we got that R times the area of triangle ADC equals to CDX over 4. We divided equation number 4 by R, and we got that the area of triangle ADC equals to CDX over 4R. And we have already found out that the area of triangle ABC equals to ABX over 4R. Here, if we combine triangle ADC with if we combine triangle ABC with triangle ADC, if we combine those two triangles together, we will get quadrilateral ABCD. Therefore, the area of quadrilateral ABCD will be equal to the area of triangle ABC plus the area of triangle ADC. Okay, the area of quadrilateral ABCD will be equal to the area of triangle ABC plus the area of triangle ADC. But we have already found out that the area of triangle ABC equals to ABX over 4R and the area of triangle ADC equals to CDX over 4R. Here we took a common factor of x over 4R out of these two expressions, and we got that the area of triangle of quadrilateral ABCD, according to equation number 1, x equals to x over 4R times AB plus CD. But we have already found out that according to equation number 2, that the area of quadrilateral ABCD equals to y over 4R times AD plus BC. We have two different expressions for the area of quadrilateral ABCD. So we multiplied equation number 1 by equation number 2, and we got that the area of quadrilateral ABCD squared equals to this expression, equals to x times y times AB plus CD times AD plus BC over 4R squared. We took a root out of equation number 3, and we got that the area of quadrilateral ABCD equals to the root of the numerator, and the root of 4r squared equals to 4r, because the root cancels the square and we left only with 4r. Here we multiply the equation number 3 by r, and we got that r times the r of quadrilateral ABCD equals to this expression over 4. Then we divided the equation number 3 by the area of quadrilateral ABCD, and we got the radius that we are looking for. We got that the radius that we are looking for equals to this expression. And then we know that xy equals to AC plus BD according to rule number 2, so we can substitute xy in equation number 3 by AC plus BD that equals to xy, so we substituted xy by AC plus BD, and we got this expression. Then the only thing that is left here to do is to calculate the area of quadrilateral ABCD, because we know all the other variables. It is given us in the question. So the area of quadrilateral ABCD equals to the root of s minus a times s minus b times s minus c times s minus d, and s equals to a plus b plus c plus d over 2. We know that a equals to b, b equals to a equals to 3, b equals to 4, c equals to 5, and d equals to 6. So a plus b plus c plus d is 3 plus 4 plus 5 plus 6 over 2 is 18 over 2 is 9, so we found out that s equals to 9, so we substituted s in this equality by 9, and we got here s minus a is 9 minus 3, s minus b is 9 minus 4, s minus c is 9 minus 5, and s minus d is 9 minus 6. So we got this expression. 9 minus 3 is 6, 9 minus 4 is 5, 9 minus 5 is 4, 9 minus 6 is 3, and the root of 6 times 5 is 30, 30 times 4 is 120, and 120 times 3 is 360. So we found out that the area of quadrilateral ABCD equals to the root of 360 square units. So we substituted the area of quadrilateral ABCD in equation number 3, this equation number 3, by the root of 360, because the area of quadrilateral ABCD equals to the root of 360 square units. Okay, so this is equation number 3 after we substituted the area of quadrilateral ABCD by the root of 360. We got this expression, and it is very simple to calculate those expressions. A equals to 3, b equals to 4, c equals to 5, and d equals to 6. So AC, A is 3, c is 5, so AC is 3 times 5 is 15. And we have BD, B is 5, D is 6, so 6 times 4 is 24. Then we have AB, A is 3, B is 4, so 3 times 4 is 12. And we have BC, CD, C is 5, D is 6, so 5 times 6 is 30. And here we have AB, AB is 3 times 4 is 12. And BC is B is 4, C is 5, so 4 times 5 is 20. So in total we got this expression. So 15 plus 24 is 39, 12 plus 30 is 42, and 18 plus 20 is 48, and the root of 39 times 42 times 38 over 360 is actually 172.9. So we found out that the radius of this circle that blocks quadrilateral ABCD equals to either the root of 172.9 over 4 units, or the radius also can be represented as R equals to 3.287 units. I will repeat again, the radius of this circle will be equal to either to the root of 172.9 over 4 units, so in terms of numbers, the radius of this circle equals to 3.287 units. Okay, thank you very much.